All right. Hello, everyone. Let's get started. Please download Laboratory 18 notebook file from Blackboard. And today we'll continue learning how to use Python codes to do simulations and compute probabilities. All right. Please run the first script to identify your host name, username, and current information. And please make sure to input your name, our number, and the title and the date, okay? We have already go through all the codes from last lab, and actually the exercises, they are not very easy, and I received many emails regarding the exercises. So today I want to spend one lab to discuss the exercises of last lab, okay? All right, so it's about the probabilities, right? So first you need to simulate the situation and then compute the probabilities. The first example is also the first exercise of last lab. It's about two dices through ones and total number is observed. We need to define a function and use a simulation to find the probability of total number is greater than 10. And actually, I have already given you the codes. And the second one is about how to compute the total score is even and greater than 7. Okay. So the first one here, let's repeat again. So first, you need to import NumPy package, right? NumPy package at NP, right? And next one here, please make sure if you are requested to define a function, you need to define a function. Okay. Define a function, and function name would be death row, and the argument you need to parse is a number of the simulation, right? And the content would be 0, and then death is a numpy.array, and from 1 to 6 is create a numpy array with a value of death 6. And after that, we can use the arguments for I in the range argument and select the values twice. It means we want to get we use these two lines of codes to simulate the dices thrown once. Okay, so it means we have two random numbers from 1 to 6, right? So that's why here we write numpy.random.choice. And after that, we need to get the total score, right? Score would be that's 1 plus that's 2, sum them up. And then we need to see the conditional selections, right? So this conditional, the first one, this example is about if the score is greater than 10, if it meets our desired condition, then we add 1 to the count. It means we want to get the numbers which meets the desired conditions, right? And after that, return counts divided by the simulation numbers. So we can compute the probability of the desired events by dividing count by the total of the trials. So that's why here you need to pass the simulation number and then return the probabilities. And please make sure to use at least 10,000. Here is a 10,000. You can set a 100,000, but at least 10,000. Okay. And after that, you can print out probability of rolling a number greater than 10 after once 10,000 rows. Oh, sorry, it's rows, not road. Is then it's like a 8.2% right? Actually, you can use round function. Actually, you can use round function to control the points after the decimal point. See here would be only 1 decimal point. Round 1, not round 1. Round 2, let me try. Yeah, so actually, because we have already multiple 100, so That makes no much sense, I think. Yeah, you can round this one, I think. You can round this number because it's already, yeah, so you can use the number itself, but you can also use the round function, right? It's about the first example. And the second one is similar. It's about the even number or and the greater than 7. So it's very important. So please make sure here you can just copy most of them. For instance, you can import the NumPy package, and after that you define this function again, right? Actually, you can define as let's like that's 02, right? 02 and set the simulations and the count is 0 and get the scores, total scores from that, and then you need to check the condition, right? It's even and the greater than 7. It means here operator would be logical operator would be and, not or any other else. So it's scalar is 10 and score divided by 2. The remainder would be 0. It's used to represent it's an even number, right? It's an even number. And after that, the result would be 25%. Okay. And actually, I see some of you said it is if score is 8 or score 10 or score 12. So it's the same, right? Because actually you translate these conditions into some other sentences, right? So for instance, in this example, because the maximum number would be 12, right? Because the maximum number of each dice is 6. So the total number would be the maximum numbers of the score would be 12. And then it needs to greater than 7. And it's an even number. So it can only be 8 or 10 or 12. So you can also use this way. All right. It's a similar. Actually, these two is exactly the same, so you can use this way. I think both they are all correct. Yeah, so it doesn't matter. Yeah, but please make sure this way. In this way, you can only use or, right? It means it can be 8 or 10 or 12, right? But in the last one, it's and. Greater than 7 and it's an even number. Okay, so it's about the first example. All right, so any questions so far? Okay, and next one is a little bit hard, right? So you see here we need to we have like 10 white balls, 20 red balls, and 30 green balls. We don't draw 5 balls with replacement and use a simulation 10,000 trials to find estimated probabilities that we draw 3 white and 2 red balls. Okay, so I think the most tricky part is about how to simulate this data, how to simulate the colors, right, and the numbers of balls. So in this way, we use the dictionaries to associate the numbers and colors. For instance, here we use the dictionary. We define a dictionary as a D, and then set the numbers, the first 10 from 0 to 9, the value would be white. So it means 10 white balls. And after that, it is red balls. From 10 to 29 is red balls, and else is green balls, right? It's about how to simulate the dictionaries. Use a dictionary to simulate the situation. And after that, set the number of the trials, how many trials, and set the outcomes. So it means the desired event, right? initial value would be outcome counter is outcome counter, right? And after that, you define another one, define another loop, right? For I in the range numpy, not numpy, is a number of the simulations and draw. And for I range of 5, it means we need to draw 5 balls. And after that, you can use a generate, you can use the append by this one is a randomly selected value, and then they are used to be the keys of the dictionary, right? And actually you can, for instance, actually I can print the draw, right? I can print the draw here, and then you will see it would be either white or red or green, right? And after that, you can use because for now it's a list. Draw is a list, right? Draw is a list, and then you can use a numpy.array to make this list into an array, and after that you can use a sum function. How many white balls, how many red balls, and how many green balls. And after that, you can use this way. If this event desired condition is met, then add 1 to the counter, outcome 1, right? So let's set is only 100 and see the output. Let's see what is the cases of the draw, okay? Check out, okay? So it means we print out all the possible, all the simulations of the balls from here, right? So you see first one green, red, green, green, right? So it's about 100, and then last one result would be 3.0%, okay? Yeah, so it's about we print out this one. So we set is like 500, check out. So it's all of them, right? So you see, not all of them met the desired conditions. So that's why we need to write one more if statement to the condition selection. So it is, oh wow, it's 0.0. Yeah, so you see it's a 0.0 in the 500 trials. So that's why here we need to try more, right? So that's why that's why I ask you like to set it as at least 10,000. And see here, it's very, very small, right? 10,000. Actually, you can set 100,000. And then you need to wait a little bit with maybe 10 seconds or 5 seconds. So you see here, run again.
Okay.
Yeah, so and the result would be different because they are all like randomly selected. So the result would be a little bit different if you run it on your own computer, right? But please make sure the code is correct. Okay, so it's about the first example, 3 white and 2 red balls. All right, so next one is about the 5 balls of the same color, right? So we can use a similar way, can use the random and then use the dictionary to simulate it, associated the numbers and colors, and set another outcome, right? And all these things is the same, but the next one you need to set if the desired condition is met. It means in this way, it's white is 3 and the red is 2, right? And please make sure to use and. But in this way, we want to represent they are the same color. So it means white is 5 or red is 5 or green is 5. And after that, the outcome 2 would be add 1 to the counter and then print out the result. Use the outcome 2 divided by the number of simulations. Result here is 3.4 about, right? Every time you write it would be different because they are, and that set is 100,000. So you see we need to wait 5 more seconds, and then it's a result. Okay. All right. So any questions so far about today's 2 exercises? Okay. I think please make sure you understand the codes and know how to simulate these situations. And okay, so actually next one is about today's exercise. It's also about probabilities. You go to a market to pick up some gourds to decorate your house for Halloween. It's a special October deal, so or you can have a 3 randomly chosen gourd for $10. Each gourd can either be a orange pumpkin or a green pumpkin or scratch. So the probability of picking each one would be, the first one would be 0.6, 0.3, and 0.1. So you need to answer the 4 questions. What is the probability of the first gourd is orange pumpkin, a second one green one, a third one the other one, 3 and the null squares, and probably at least 1. So you need to finish them and print out the result. Okay, so I have 4 separate cells for you, and if you don't know how to solve the questions, you can check the result. You can check the codes of the last example of lab 17. Okay, so here at least 1, or you see here is about at least right, at least sorry, at least 1, at least 6 in D6. So it's to answer the last one. It's I think it's the tricky part. Yeah, for other things I think it's not very hard. Yeah, it's about today's exercise. Yeah, so all right, so that's all I want to share today. If you don't have any other questions, please feel free to leave the meeting. Have a nice week and have a nice spring break. And yeah, thank you guys. If you have questions, you can stay here. We can discuss more. Yeah. How can you write the code, or just you need to write? Of course, you need to write the codes to answer these questions. You need to show how to use the code to print out your answer. Yeah. Okay. Thank you guys.